Hopefully you've given this one a try. It's a practice problem on valence bond theory. I'm going to walk through the solution now. So if you want to pause and try it yourself first, if you haven't done so already, please do. All right, so for this one, we're looking at CH2O. And the first step to any of these problems will always be to draw the Lewis dot structure. So hopefully that's starting to come pretty easily to you now. I'm just going to go ahead and draw it out rather than walk through it slowly. I'm going to have carbon in the middle. I'm going to have two hydrogens. Here, I'll do it like this. And I'm going to form a double bond to an oxygen that'll have two electrons as lone pairs. So after I have a Lewis dot structure, I can then predict the geometry using VSEPR theory. And so looking at this one, I have three electron groups around the carbon. So that's going to predict a geometry that is, and I have 0 lone pairs, trigonal planar, with bond angles of 120 degrees. And I can draw that out if it helps too. I can write out my hydrogen at kind of a 120 degrees away and to an oxygen. And so it should look something like this. So now once I have this kind of 3D picture that I'm expecting, I can look at the hybridization at the central atom. And so I'm going to focus on the carbon for this. So looking at that carbon, I can see that I have 3 bonding domains or 3 groups that are bonding, or 3 electron groups. I feel like we've used so many different words for this. So 3 bonding domains, 3 bonding groups. And so that means I'm going to need to be able to have an orbital with 1 electron for each of those 3. So that tells me I'm going to need to have 3 hybridized orbitals. Looking at carbon, it's in that second column, so it only has a 2s and the 2p orbitals that are in its valence shell. And so I'm going to take the 3 that I need, which is going to end up being 1s and 2p's. So I'm going to make sp2 hybridized orbitals, and there's still going to be a p orbital left over. So that leftover one's still here, and we have these sp2 ones. I'm going to go ahead and add my electrons to this. I've got 4 valence electrons for carbon. So I've got 1, 2, 3, 4. I've got 1 electron in each. Great. So with that, I can predict that the hybridization on my carbon is going to be sp2. So now I'm going to sketch out a picture of this and show my bonding orbitals and my atomic orbitals and give a whole picture. And then I can also point out my sigma and my pi bonds as well. So I'm going to start with that carbon in the middle. And I'm going to create its hybridized orbitals here in blue. So I've got 3. I'm going to space them 120 degrees apart. So I'm going to go 1, 2, 3. And just because I kind of know where this is going, and I'm going to make these coming out and going back just to make it easier to see the p orbital. So I have those hybridized ones, and I also have a p orbital still. And in my p orbital, I have 1 electron, and in each of my hybridized orbitals, I have 1 electron as well. Okay, so now this carbon can actually start bonding. I'm going to do the hydrogens first. They only have an s orbital. They're really straightforward. So they're just going to come and overlap with this carbon hybridized orbital. So here's my hydrogen for each of these right here, hydrogen, and bring 1 electron to share. And so now I have paired electrons in the overlap of my hydrogen and my carbon hybridized orbital. All right, next it needs to bond to an oxygen. So that'll come in next. So here's my oxygen. And my oxygen atom is in my second row as well. So it has only s and p orbitals to work with. And it's only going to bond to one thing, but my oxygen is then going to have 2 lone pairs. So that oxygen has 1 bonded atom and 2 lone pairs, which is 3 groups. So this tells me it's going to, just like carbon, be sp2 hybridized. So I expect my oxygen then to, here we go, have 3 of these hybridized orbitals and 1 p orbital. And within it, I have 1 electron that's going to overlap with the carbon hybridized orbital and form a bond. And my other 2 hybridized orbitals have the lone pairs within them. If you want to see this written out here like we did before, if I have my sp squared and then my p. So my oxygen has 6. I'll go 1, 2, 3, 4, 5, 6. And so you can see my lone pairs would be these 2 right here, which I place right there. And then I have 1 that's going to be able to form a bond with carbon that's a sigma bond, and another that'll form a bond with carbon that's a pi bond. All right, so now these, I've got these hybridized orbitals that are overlapping between carbon and oxygen, but also there is an electron in the, sorry, p orbital. And so I'm going to see these overlap as they come together as well. And I just draw 2 lines between them. You could also draw it so it looks like that as well if you prefer. That's another way to draw it. Cool. So I have a picture of how this is bonding, which is fantastic. And like going through and labeling a little bit, I could say I have right here a sigma bond, and I have a sigma bond at these carbon and hydrogen bonds as well. And I have a pi bond that is between my carbon and my oxygen. So I have 3 sigma bonds and 1 pi bond in this molecule. And I've got this kind of nice picture of how it looks.